So let us look at another problem. Actually, this problem you can easily solve using the fundamental principles of counting, uh, which we have covered an example like this before, but I just wanted you to use the permutation notation to solve this problem. Once you get familiar with the notation, then you can use either of the two methods, because like we know that behind permutations is fundamental principles of counting, the derivation of the formula for permutations. So the question is, how many numbers lying between 100 and 1000 can be formed using the digits 0 to 5 without the repetition of digits? So I'll give you the choices for this. I have 100, 80, 120 and 60. The correct answer is 100. So let us look at the solution. What does it mean to have numbers between 100 and 1000? Basically, all the numbers between 100 and 1000 are 3-digit numbers. So we have to find 3-digit numbers formed by 6 distinct objects. I'm just using the word distinct so that you get the idea that we are trying to use permutation notation, right? That is for distinct objects. So here we have distinct objects. All these 6 digits are different. And we have to form 3-digit numbers. That means that we have 3 boxes, right, corresponding to this 3 digits of the number. So from 6-digit distinct objects, we take how many at a time we'll take to fill this 3? 3, right? So you have to take 3 at a time. So that would mean this notation, 6 distinct objects taken 3 at a time. This is the number of permutations possible, right? So what do you think is the problem with this? Is this going to be the right answer? If not, why? Just think about it. We have also spoken about it before that you can have numbers like 012 or 013 also, right, included in 6p3. Why? Because from these 6 digits, any 3 can be picked and arranged in these 3 boxes. So these 3 are also choices which are right. But are they 3-digit numbers? No, right? Because we want numbers between 100 and 1000, and these are actually two-digit number because of what? Because of 0 being in the first place. So 6p3 actually is equal to the 3-digit numbers plus numbers starting with 0, right? So all numbers that start with 0, like 012, 6p3 consists of the 3-digit numbers which are between 100 and 1000 and the numbers starting with 0. So how do you get these 3-digit numbers then? You basically have to subtract from. So if I just do 3-digit numbers, is basically just subtracting 6p3 from the numbers starting with 0, right? Let me go to the next page just to find the numbers starting with 0. So numbers starting with 0 formed from 0, 1, 2, 3, 4 and 5, right? So we have a 3-digit number. All the 3-digit numbers with 0 actually always coming in the first place. So how many boxes we have left? We have just 2 boxes left, right? And now how many objects do we use to fill these 2 boxes? So 0 is already used here, so 0 is gone. So we have only 5 objects left, right? So 5 objects taken 2 at a time, right? That's how you think in terms of permutation notation. So numbers starting with 0 found from this, they are equal to 5, because you have 5 objects and you want to take 2 at a time, so it will be 5p2, right? So this will be basically, if you look at what I wrote before, here you just had 3 digit numbers is equal to 6p3 minus numbers starting with 0. So basically you have 3 digit numbers equal to 6p3 minus 5p2, right? So you should be able to compute it very quickly now. I'll just write everything like 6 factorial divided by 6 minus 3 factorial minus 5 factorial divided by 5 minus 2 factorial. But you should be able to compute it faster and faster with practice. And this will be equal to 6 into 5 into 4 minus 5 into 4, right? And this is equal to, this is 120, 30 into 4, and this will be 100. So this is the answer. We could have also solved this question. Let me go to the next page using what we did before, just using fundamental principles of counting. We have these 3 boxes, right? There was another method. I call it method 2 here, but you had used it before. So here you have 3 digit numbers to be formed from 0, 1, 2, 3, 4 and 5. And how many options do you have to fill the first box? Only 5, right? Because 0 cannot occur in the first box. So you will have 5 options. For the second box, you will again have 5 options because one of the options from 1 to 5 will be used and 0 is available for the second box. So you have 5 options again, and for the third box you have one less option. You have 5 and 5 and 4. So 3 digit numbers are, from fundamental principles of counting, just 5 into 5 into 4. And here again you get the answer as 100, right? So I just wanted to show you that sometimes this method is actually shorter than using the permutation notation. So feel free, unless you are specifically asked to use the permutation notation, to actually solve it in any way. Because permutation is, I want to stress this point, is still based on fundamental principles of counting, as the proof of the formula shows. It is just a compact way of representing the arrangements, and so that you don't have to calculate so many times. But here, actually looking at fundamental principles of counting is useful because we can easily take care of the case that 0 cannot occur in the first place. So please try to solve it using different means, and you will get practice and know what to use when. Thanks.